So when you remember that when these little devices, they were new. Before that, we only had the web and we had browsers and we had big computers. And these things, they started to create, we started to look at design patterns differently. And I was always amazed that our websites, they all looked the same, even back when these things came up. And these things taught us things like, maybe the logo doesn't have to be in the left top corner, right? Maybe you can put it in the footer or leave it out completely. So these are disruptive things and we can learn from them. They can teach us things that we didn't know before. And then these things came and we dozed off again and all our websites look the same again, like Andy taught us yesterday morning. So maybe we need other professions, new things, completely new things to learn from. And that's why I'm so excited about this talk. Another thing that got me really, really excited was when I read the bio of Mark. Now, if you look at all the bios of all the speakers here today, they'll all say a speaker, a designer, author, publisher, but Mark not. No, Mark is an author and a scientist. And an artist and a scientist. And we should have many, many more artists and scientists on stages. So please give a very warm welcome to Mark Melnykowycz.
Thank you very much for the introduction, and thank you for letting me speak here. So I'm a artist engineer, artist scientist. So I look at the content creation, how we've been producing VR content up until now. I wasn't exactly sure what the whole makeup of the audience would be, so there's going to be a bit of a talk about technology trends, what's the state of VR this month, let's say to the end of the year, and how it's probably going to change in 2017. How we're approaching design for VR content, also collection of VR content, and then also the perspective for the user needs, because this is really the most important thing, to make sure that you're creating content that's not only engaging, but things that people can consume in a nice way. So when I think about VR right now, I think about magic. I think about the concept of magic and quantum computing, like these things I don't understand. You know, if you show me a giant face coming up in front of me, and I can see it, and maybe I can almost touch it. I know it's there, but I don't know where it came from. And so then if a person says, okay, and now we want to make a giant face of you floating above the city, I'll say, wow, that's awesome. How much does it cost? And they'll probably charge me 10,000 francs or something. So anytime there's a new technology wave coming, you might have noticed that there's always some opportunities, some business opportunities to get higher contracts for doing things, as long as you understand what is happening with that technology. If you don't understand, then you get a giant bill from the developers or from other content strategists. So the first thing I wanted to do is sort of dispel the idea of VR being like some sort of crazy magical thing, because it's hyped so much right now that you probably get the impression, if you don't know anything about it, that it's some magic giant professor wizard off to the center of the stage. When in actuality, the virtual reality, the new technologies, it's a little guy sitting back there who knew how to put together a few things and giving you a great experience. And what I want to do is give you a better perspective on how to create your own virtual reality experiences. Or to understand, when you're working on VR projects, the different components that are going into the entire production. But VR is nothing new, actually. It's just exploding on the consumer market right now, and there's a lot of opportunities for it, but there's research going back to 1965. In the 1950s, we had this Sensorion. It was kind of like an arcade machine, and it would blow wind at you. And now you can buy VR masks that also blow wind at you. So the interaction between virtual forces that are around us and virtual images that are in front of us, I mean, we've had stereoscopic images going back until like over 100 years ago. And then we had a lot of experiments in the 1990s. We had the Virtual Boy from Nintendo, which you could probably buy for 20 bucks in 1998 because it made everyone sick and it was horrible. And then we are at the stage now where you can actually throw together your own DIY VR headset with cardboard and some smartphone screens and some computing processing ability, and then you have to ask yourself, where are we at the consumer level? You know, we can create really great experiences now, but they have to be good experiences, not just interesting technologies. So the artist in me thinks, okay, there's this great new accessibility to technology that I can use to tell stories, create new experiences, but you know, at the end, what is art? I mean, it's a form, it's a function, there's a medium, right? Paint is a medium, it's a thing that you see, it's physical. And that's what we're used to create paintings with, or we sculpt with stone and a chisel, i.e. we have tools, we have medium and we have tools. We don't just have a thing called virtual reality, which is, a lot of people call it the new medium, you know, for like the 2020 or 2016, 2017, it's like you can paint all these great, cool experiences of virtual reality, but they don't actually say what it is, because at the end of the day, what we want to do is create good experiences. Now, we can do things like have 360-degree videos in South Sudan, so we can empathize with the people on the ground, we can understand the problems that they're having with war coming to their country. We can go to New York. There's a very cool film called Blackout VR, which is being created, where they actually do volumetric video capture in the subway, and then they're taking the holograms of the people, of their characters, and putting it into the 3D environment that they've created. One of the things I'm working on right now is a Car Hub test drive. It's a test driving for cars, as the name would suggest. And I've also worked on other films, like a small VR film, 360 capture with monoscopic cameras. And then also we bring these things together into the developer environment. And other people are doing even crazier things. They're teaching people how to parachute using VR technology. They're teaching surgeons how to do surgery, so they learn how to do things before opening you up. So hopefully to reduce the learning curve. During the Olympics this year, there were journalists who were not in Rio, so they used virtual reality, they used live streaming with a Samsung device, so that the journalists could look through the device and, you know, teleport to Rio and talk to the athletes to get an interview. So there's really this whole giant plethora of things that you can do with virtual reality. And as designers, you're in such a great position right now to help define what a good VR experience is going to be. And you have to be able to do this, because if we don't create good VR experiences, then the technology will probably go down and die again, because people won't see any need for it. So when we think about VR now, we're in this technology trend. We talked a little bit about the smartphone in the introduction. Now we've gone from a very static computing environment to a slightly ubiquitous environment. Now, probably there's a lot of people here in the room that don't have a desktop computer anymore. I only have one because I want to make VR experiences. We've gone from having a laptop to having something that's a tablet or a laptop, and we still use a keyboard, but you know, a lot of times I'll try and hit the screen of my MacBook Pro, and it doesn't really do anything because I've learned that interaction pattern from playing on my iPad. So now the question is, what is the interaction environment? What are the rules of the interaction for virtual reality? This is actually one of the principal giant questions that we have. Because you know, if users don't know how to use your device or how to use your website or your mobile application, that's a barrier. And if they're spending, you know, more than 0.5 seconds on Google, then their revenue goes down by, I don't know, $10,000, $100,000. So right now, we're at the point where virtual reality is available. It's not mass market. Hopefully it will be much bigger next year. And then after that, we're going to have augmented reality, Microsoft HoloLens. We had the experiment with the Google Glass, which was also considered augmented reality, but we couldn't really overlay any cool animations. And even if you pay $3,000 for a HoloLens, you just get like this small window of interactivity. It's really not worth it unless you have a very, very good reason for it. But this is bringing up the principal question: when we have this ubiquitous world, how are we going to teach users efficiently, quickly, and reliably how to use the programs and new hardware devices? And if we consider the different use cases now for immersive environments, I made the name of the talk immersive environments principally because if you know how to design something for virtual reality, changing over to augmented reality is not going to be that difficult because a lot of the tools are pretty much the same. And then we also have the concept from Star Wars, the holodeck. If you don't want to infringe on copyrights or anything, you call it a cave, an immersive cave, where you use projection mapping. So I'd have a projector here or here, and then it makes that wall, it makes this wall, it makes that wall. But the way that the people have to learn how to interact with it are all going to be the same. I mean, to me, it's just something over there that I can't touch. It's virtual. Doesn't matter if it's a cave, if it's virtual reality, or if it's mixed reality. The question is, a good example, and I'll be talking about this as my little prop for the evening. This is the HTC Vive controller. This is interesting because it's a completely different controller design. No one has had to use this before. But it's actually very easy. If you look in the left lower right-hand corner of the screen, when you're in the virtual environment with the HTC Vive, with the Starseed game, you see your hands. I don't feel my hand, I feel a controller, but I don't see it. But I know that if I click it, then my hand will open and close in the virtual environment. So they allow a very simple action to have what is actually a very complex action. If you think about all the tendons and muscles that are moving in your hand to do this simple finger up and down, it's very nice to avoid all that in the virtual world. So this is where the state of virtual reality is right now. It's there. There are ways to interact with it. There's going to be a lot of different devices coming up. We're going to talk about a few of them here and how people can interact with the environments. And that's how we come to VR hardware. So when we talk about VR hardware, we first want to think about why are users using these experiences? Why are they putting on a Vive or an Oculus Rift? Well, when in creating content, I basically see two broad columns occurring. What I call experiential, meaning that it's mainly going to be a passive experience. So if you're going to a film, you're watching the film. You're not really expecting to talk to the actor on the screen. You're not expecting to interact with a shooting environment. You're expecting to lay back and absorb that information. If you're in a game, then you expect to do something in the game. You expect that there will be some sort of game mechanics, a certain way of shooting, a certain way of wielding a lightsaber, where I have to be interactive. And I think it's really important for users to know what to expect if they are going to pay $30, $40, or $60 or francs for the thing that you've designed. Because this is another problem. Content in VR is still a little bit bare. And if I don't know what exactly this is going to be, why should I pay money? And if I don't pay money, then you don't have an economic system of virtual reality growing and becoming successful. But also from the content creation viewpoint, if I know I'm going to be doing a film and that's going to have lower interactivity, then I'm going to create the experience primarily with film and video cameras. I probably won't create everything in Unity or in another game development engine. The other point is how is the person physically existing in that environment? Are they standing, like I'm standing now? Are they sitting at a chair? Because this very simple thing between being up, having freedom of movement, or sitting down, maybe I could be doing a yoga position, is going to dramatically affect the range of motion that I have with controllers, and also the range of motion that I have with my body. I mean, you're sitting down right now. If you look this way, you look that way, how far can you actually move? What is actually comfortable, right? I mean, these are the barriers that you're going to run into. Because if a director says, oh, well, we want to shoot this film where now there's this giant monster coming up from behind, and then another one comes from over here. So then the user has to go like this way and that way. I mean, that's disorienting. That's not really that enjoyable. And I think as UX people, even if you're working on a film or you're working on an application, there are people who can say, look, there's specific ways that people feel comfortable. We know specific patterns, and we have to fit the experience to those patterns. Now, when we talked a little bit about technology landscape, in Europe, primarily you have the HTC Vive. I don't think the Oculus has even started shipping here yet. It's only in the US. And at the end of the year, we're going to have PlayStation VR. Apparently, it sold out faster than any sort of PlayStation ever provided by Sony. And if you look here, you see a bit of a fragmentation. HTC Vive, really cool, weird controllers. In addition, I have to have two, well, they call them like lighthouses. Essentially, it would be like one IR camera here and one IR camera here. And then it can position where I am in space. It'll do that by knowing where this is, knowing where this is. And if I have my Vive on, then it'll know where my head is. It will also know which way these things are pointing, and it uses this to orient the user in the three-dimensional space. Now, the same can be done for the Oculus Rift. You also have head tracking, and in the first iteration, it's only coming with a controller, like a normal Xbox controller, which means when you're moving in the virtual environment, you're going to be using the same interaction patterns that you would normally use for an Xbox or a PlayStation. The HTC Vive, we have a different situation. We have controllers here where I can push, and theoretically you could design so that when I push here, I very quickly move this way. Or we could say, hey, I want to raycast. So a very basic element of game design. You can say that there's a laser going this way, everywhere in the direction my face is. And so then I can use my gaze, and if I leave it there for more than 2 seconds, then the program could say that it could assume that I want to move that way. And for PlayStation VR, it's also going to be using a controller very similar to HTC Vive, but additionally, you could also have wands that you can buy separately. So as you can imagine, this is going to create maybe a little bit of confusion between users about what to expect, and also for you to know what you should actually be designing for. Then you have the mobile VR landscape. Now, the difference between the mobile and the high-end landscape is essentially going back to what I discussed before about more of a passive experiential or an active interface, or an active experience. Right now we have the Google Cardboard. Many of you have probably seen these cheap cardboard things. They work, they're cool. Depends on how good your phone is. My phone is mid-range Xiaomi. It's not spectacular, but it works. We can also have better devices, so the device can actually sit on my head, or I could hold it up and look this way and that way. And then we have what is considered to be the best, or actually, it is one of the most successful, if not, yeah, it is the most successful HMD so far, the Samsung Gear. The new one has just come out. And at the end of the year, Google Daydream should be releasing their first phones, which is to say that their partner companies will be releasing Daydream phones, which should have capabilities on par with the Gear VR. And again, we have a bit of a fragmentation in how to actually interact. So if I think about designing for Google Cardboard, I'm expecting that the person won't be able to really do much, because basically the only thing you can do is gaze one way and gaze the other way. There's some buttons that you can interact with, but they usually don't work that well, so you probably want to avoid them, or at least I do. And it is possible to have a normal controller, and Samsung even demoed these really cool controllers at CES where it fits on your hand, and it also has an accelerometer in it, so it can track the 3D movement of your hand, and then it creates a virtual keyboard. But they're not releasing it, apparently. Maybe they will in the future, but it's very uncertain. So you have to be somewhat conservative in how you're actually going to design for the VR environments. So now I'm going to jump back to VR media a bit. I talked about it a little bit. I'm trying to give you like little bits of information here and there, and then bring it all together in a cohesive story throughout the talk. So, you know what a film is? With a film, you have a camera, and it shoots, and it creates a 16:9 or a 3:4 film window. And then with VR, essentially what we're doing, we have very high wide-angle lenses. So the lens would cover an area of maybe 180 to 220 degrees. And then we can combine two images together, so we can create an entire sphere. And then the user, you, essentially, when you're viewing the video, you're in the middle of that sphere, and then the images are all around you. And then so you're playing in a 360 movie. Most of these are only monoscopic. So I think many of you understand, the idea of stereo vision, right? If you put your hand here and you look at it with one eye and then the other eye, you see that there's a shift between the two. I mean, that's the great thing about us as humans. We have stereo vision, so we get depth perception. And the depth perception is very interesting because that's what makes VR more realistic. If you're looking at just a film, it's flat. But if I'm looking at a person, I get a feeling of depth. I understand that there's, I don't know, like 1 to 2 meters here, and then, it's like you're 3 meters away, I think. I'm still getting used to metrics somehow. And then at the same time, we have the normal 3D assets that we've been creating for decades with game design. In many ways, game designers are in the best position to capitalize on virtual reality right now, because a lot of the tools that we're using to create VR worlds are game development tools. We're using Unity, Unreal Engine, create 3D models and 3D Max or another 3D modeling program, or perhaps we create a 3D scan of a person and then we animate that person, and then the programmer tells them how to move through the 3D world. And we also have volumetric video, which is essentially capturing the depth information, the 3D scan of a person, and overlaying it with the color information from a camera. And so then we have a hologram. So we have actually a huge multitude of media right now to work with. It's not just having a picture or having an image. It's having a whole plethora, a palette. It's a palette of media that we can use to create these environments. So these are a few examples of some of the tools that we use for capturing VR. The 360 camera is over on the right-hand side of your screen. This is one of these cameras, which is an array of 6 GoPros put together. And we shoot all the GoPros at once, and then we stitch all the information together, which is in the middle of your screen, using color software, which was bought by GoPro. At the same time, we can put together Microsoft Kinect plus a video camera, and we get this depth, this volumetric video capture, which you can see in the, I kind of feel like I should be pointing with these. But you can see in the middle of the screen where the front of my body is captured quite nicely, and then you see these streams coming off the back, and that's essentially just the depth information that it's capturing. Or we just capture a 3D scan. I go to a museum, I take my iPad with my scanner, and I discreetly scan an object I want to use in a game. Or I could scan a person. And then after that, we have our content. Maybe we have a story. We want to create a world. This is one of the most interesting things about virtual reality. You're essentially like a god, because you're creating the world that the user is existing in. You're not just creating an application that they're interfacing with, you are creating their environment. You're creating how that environment interacts with that user. So, do we need to be on Earth? We could be on Mars, we could be on the moon. We could model how the gravity is changing in different environments. We can model how things are colliding with one another. So we can make them collide in the ways we want, the ways we expect as from normal physics, or it could be a totally different world. And we're also designing how the objects within the world are interacting with one another. So I can say that the tree should have a certain breeze. I could say that this giraffe, it is a giraffe, by the way. It's an origami giraffe. The way that this giraffe is talking or speaking, and the way it's interacting with the rest of the world can be defined through an artificial intelligence script. So we have this very beautiful, the mediums of VR are essentially the 3D modeling, the code, and your imagination. So when you bring all these together, we have to think about our design space. Now, we talked about this a little bit. As with many design patterns, you don't have to start from scratch. There's already been a good deal of research. Samsung has done a lot of work. Also, there's a very good talk by Mike Alger, where he's brought together a lot of these concepts for his master's thesis in England, where we already know that we have a very defined region, a comfort zone for the user to the top, looking to the right, looking to the left. So we don't have to recreate all this stuff. We just have to use it. We have to put these together in one concise way that we can go to stakeholders, or we're talking to a director on a film, or you're talking to your developers and to your coders, and so that everyone is talking the same language, or at least understanding what needs to be done. So I'm sure we've all had problems before where you try to design something and then it goes to a development team and then there's a bit of iteration going back and forth when someone says they like something or they don't like something. So the concept of speaking the same language, being on the same page is going to come up again at the end of the talk. But I did want to hit upon user interfaces, because so far we've just been talking about the idea of being in a VR world. But there was already some cool solutions coming up for interacting with that world. Because if you think again, if I have these two controllers, I can't type on a screen, and I can't use a mouse. So the question is, how am I interacting with that world? It's actually quite a hassle. Sometimes you open up a program, maybe it's a cool music creation program, and you're like, you want to do more, but you can't. So we have to find interesting solutions for UIs, for specific programs, so that users can interact and that they can learn those interaction patterns quickly. Tilt brush is really interesting because I'd say as a VR program, it's probably gone through more development than a lot of other programs just because it was one of the first and it's been released and it's gone through a lot of testing. So it's really cool. Essentially, on one hand, you have a tilt brush that's accessing your UI. On the other hand, you're using your tilt brush, which you would draw with. And so I would point here, and then 3 planes come up. And I can look here, I can look this way, I can look that way, and then I just point, I pick a new color, I pick a new brush, and then I go back to creating. And so it's a very fluid, very easy way to access a UI, create an interaction in the environment, do an undo, go back and forth between the two. That's a little bit different than Envelop VR. Envelop VR is one of the first applications coming out, which is trying to give you everything at once. Essentially, you're sitting at your computer, and it's really cool because it allows you to access your keyboard and actually it gives you an outline of where your keyboard is, which is quite nice. Because normally you have to, you don't know where you are. You're immersed. You're in another world. So now with Envelop VR, you got screens like all around you. And then the problem is that I can kind of point with this, but then my keyboard is here. And then I can use my mouse, but then I have to be on the right screen. So it's a cool idea, but I think it's a great example where you're taking the classic two-dimensional screen that we're used to, superimposing it onto the virtual world, and expecting it to work. And it does work, but when I interact in a volumetric state, I want to interact in a volumetric state. And you also have a lot of limitations with the resolution of HMDs, so that you can't really read text as well. So there's a lot of technology limitations that we have to be aware of when we're designing experiences. But one of the great things about VR is that, especially with controllers where you're mimicking your hand movement, it is actually very natural. It's very natural to learn how to use devices. It's very natural to learn how to open and close your hands if it's been designed in a fluid way. One of my favorite games is a zombie shooter game, just because it's very easy to get into, and because for the first time, it actually feels like you're shooting a gun. Not that you can't do that. I mean, I'm an American, so I do have some experience shooting real guns, but I don't want to really own a gun. I don't really have any need for it. I don't have much of a desire for it. But the immersive experience of sitting and holding your gun like this, or actually, you actually have a katana. So what you do, you have a katana from the back, and then a zombie is coming here, and then you can like shoot there. And I was really amazed at how fluid this all became to me, because the idea of having a katana in front of me, and then having my gun here, all of a sudden it felt like normal. It felt like very comfortable. And I wasn't really expecting that. I was just expecting that this would be kind of stupid. So I was really amazed at how easy it is to immerse yourself in a new environment and take on new user behaviors without very much interaction, learning. And that's why when I think about experience design for VR, I'm thinking about the convergence of three things. We already know a lot from film and theater about how characters are going to be in a set. How a character will need to interact with the world. We already know from game design how to create these things, how to create a story that's, let's say, more mechanics-driven, although you can have a story in a game that's also very game-driven. In film and theater, many times you'll have a narrative-driven story, or people will just, it's an action flick. Like, you just want to see Harley, with her baseball bat, hitting some zombie thing. And, they can both be fun experiences, but you go to movies for different reasons. And that's where then the user experience will come in to bring these two together. That's actually one reason why it's really interesting for me, because it's the convergence of story and technology together with human movement and existing in a world. So when we think about story has structure. I mean, you don't just have an author who starts writing and then they just create some amazing story. UX has forms, UX has rules, and story has form, and story has rules. So this is some of the examples that you can start to think about how to think about a story in a systematic way, where the environment of the world that you're building is influencing the storyline. Now this is done in film all the time. If you think about Superman, for example, Krypton is destroyed. Why was Krypton destroyed? Because the Kryptonians were mining their environment until it was dead. They created their own problem. Minority Report was a great example. Minority Report, they had a lot of crime, and then they found this way to predict crime, and then all of a sudden people wanted to be in a safe environment, so the city built up in a large vertical way, which necessitated the need for these cars that were going up onto the building like an elevator. So world design is a key way to drive character and plot. That's going to be true in game design. It is true in game design. It's going to be very true in virtual reality as well. So it's important to have an understanding for that concept, even if you're not the main author or writer. Because how the user is interacting with the world and how the world is directing the user, they're two intertwined things. If I have a wall here, then I have to go around it. That's the law of the world that I've built. I could also build a world where I can go through it. A very simple interaction, but it makes a huge difference in the storyline. And so a lot of times it's important to be cognizant of this tension, let's say, between what the character is doing and what the world allows the character to do. And this would generally be a larger process, but it's very important because depending on what world you want to build, you're going to have different 3D assets, you're going to have different coding requirements potentially, you're going to have different necessity for creating assets or shooting a film. And depending on how the character, your intention for the character, this can all change very quickly. It's great to have it early on. This is Kickstarter, Mythica VR. It's very cool because it's one of the first games I've seen where they're trying to really play with the idea of Dungeons and Dragons plus avatars and having people interact in the world as those characters. This is one of the great things about D&D, that you take on the persona of a character and you become that character. So one of the big things I think that's going to be interesting considering empathy, emotional response, and user behavior, is how people are taking on their new personas if they have a different avatar. It doesn't have to be, an avatar like this cool ogre. I mean, you could be, right now, people are sometimes a basketball on Facebook, or they're a little kitten, they're a cat. They can take on these different attributes, and the virtual environment is going to allow them to live those avatars much more deeply than before. Coming back to hardware and interactivity, I mentioned that it felt really natural somehow to shoot zombies with these things, even though they're not a gun. But the next stage, and this is going to be also kind of, I don't want to say fragmented, because I think when we have these specialized tools for virtual reality, for example, on the lower left-hand side of the screen, this is essentially it's like a treadmill for VR. Essentially, it has a frictionless surface, and then you can run in place. So you can run through Battlefield Earth, or you could run a marathon on the Jungfrau, I suppose. And it's been in development for a long time. I don't know when it's actually going to be released. And it's not a new concept either. We also had this in the late 90s. The idea was to have an arcade, a VR arcade, where people would step in, strap on, and then do their thing in the world that they were in. But we're also going to have much more realistic things. The gun, it comes up because it's going to be the most popular. This striker gun in particular, it's supposed to give you more of a haptic feedback. The Vive controllers actually give you a bit of a haptic feedback too. It's like a small vibration. I imagine this one is going to be bigger, because bigger guns, bigger noise. I don't know. But the other point is mobile. We talked earlier about mobile VR and the idea that it's doable, but you have it's not as immersive. The reason it's not as immersive is simply because generally the screens aren't having a refresh rate that's going to be as high, it won't be as high quality, and also they're smaller devices. They heat up a lot faster. So one of the other aspects that is coming, and will probably be interesting for internal VR experiences like a theme park or training, will be the backpack computer. So you have your i7 computer with your 1080 GPU. You plug in your VR headset and your Vive, and then all of a sudden you can walk around, and you don't have a cord that's pulling your head back when you go too far. So this is one of the most interesting points for me. How are we going to create new things that people want to use, and that are really going to give them value? And it's not just the gun. The gun is the most accessible because a lot of people love it. But we also have a great project in Switzerland called Birdly. Birdly is a VR experience that allows you to fly like a bird. So you have a fan coming, you get the feeling of wind, and then the way that the structure is moving, it gives you the sensation of flapping like a bird. Something you never feel before, if you didn't have a VR environment. But it doesn't have to be, I think these things cost something like $100,000 to make, and it doesn't have to be that complex. You can see pictures from Thailand where there's a guy sitting in a chair, and then they're shaking him because he's doing a VR earthquake experience. If you just change the person's environment a little bit, it will dramatically enhance the immersion. Because once you're in the Vive, you have immersion optically and also from your ears. And so then any small movement, your body is going to try and follow what is happening on the screen, because you're setting the stage for that. The chair is actually moving right and left. And so this also brings up some other interesting points, because if you push down on the chair with your feet, it will propel you forward. So they're trying to introduce a different locomotion possibility using their hardware. And also driving, racing games are going to be completely amazing, I'm sure. And so I'm looking forward to potentially going to an arcade. I'm not really sure about the bike, but, I guess for triathletes would be cool. The other thing that people so as a scientist, one of the things I work with is strain-mounted sensors for the body, polymer sensors. And everyone's always talking about the gloves, because our ultimate goal is not to necessarily have a controller. One of the ultimate goals is to not have a controller and to interact with the world in a very natural way, called natural user interface, It's a big research topic, has been for a long time. And we're getting to the point where technology is catching up with what we want to produce for consumer products. The Dexmo is essentially this hybrid skeletal glove which is giving you feedback. So the idea is that, and this is one of the problems I always have with VR gloves, is that you want to have a tactile feedback. It's great to hold a controller because it gives me security. I know how to interact with it. I know where it is. If I just have a glove, and if anyone has ever tried to do this with some of the IR cameras, you know, they'll have a demo where you have to like grab a cube and then like drop it, and you're like, okay, I kind of have the cube, but I'm not sure, because if you think about your hand is actually quite horrible at positioning itself. If we think back to the mouse, one of the greatest things about the mouse is that you can put it somewhere on your screen and you can go away and it's still there, right? Think about the computer. You've designed a user interface. The user has done something. They've clicked on a button. They go back for a coffee. They come back 2 hours later. The computer comes back on. The mouse is still there. You can't do that with your hand. I mean, if just like try pointing somewhere, try directing somewhere. There's a lot of virtual reality and augmented reality demos where they try and show people like pointing in like on a virtual computer. I'm like, nobody wants to do that. That's even with the controllers, like you can point this way and that way. But think about that. There's a mass on my arm right now. How long am I really going to be able to hold that? How long can I hold? You don't have precision with it. I get lazy. I've only had the Vive for like not that long, but if I'm pointing at somewhere on the screen, I actually like start doing it from the hip, like. It's natural. Everything in the universe wants to use the least amount of energy possible. That's physics, and that's also UX. You don't want to make the user have to move if they don't need to do the experience. And you shouldn't overcomplicate your experience because you think that the user has to move. Okay, coming back to trying to bring everything together. Storyboarding is one of the most, I don't want to say oldest, but I think it's one of the most easily accessible ways to pre-visualize what's happening in a film. And even though we have tons of cool pre-visualization software, the normal drawn-out storyboard is still used quite a bit in film and Hollywood to do conceptual ideas before you start really producing the scenes in the film. And this is exactly what VR needs as well. If we're creating a story diagram and we can do it systematically, that we say, you know, the character comes here, they come into the world, there's these zombies coming from this side, or they hear something, there's a spaceship coming from that side, and then we want to plan out or predict what the user is going to do, the storyboard is a great way to do it. And you don't have to have a professional storyboarder to do this. It helps. But it's just to give the idea that we want to pre-visualize our scenes the same way that we do rapid prototyping for mobile or web development. And this is very analogous or very easy to get into with Unity. Because if we look at a game development engine, I use Unity because it's free and pretty much Unity has still the best support for VR. If you're looking at a plethora of VR devices, you know, there's always an SDK for whatever you want to use, whether it's HoloLens or Vive or Oculus Rift. There's also Unreal Engine and some other very good developer platforms. But with Unity, it's accessible. So a lot of people use it. And what you're generally presented with is two views. You have your three-dimensional world that you've created up top, and then below that you have your camera. This is one of the most fundamental things when thinking about VR. When you think about the user, you're thinking about a camera. I have a camera on my head, and wherever I look, that's where a ray is being cast, and that's how I'm going to move in the world. And once you set up, like Unity it's kind of weird because on the one hand, it seems very complex because you can do a lot of coding and there's like C#. And on the other hand, there's a lot of 3D elements, and it seems like a big, difficult world at first, but it's very intuitive. All you're doing is you're pulling in your assets, your 3D models, maybe you buy them from the asset store, you pre-visualize what's happening, you play your scene, and you see what's happening. And it gives you a very intuitive way to show what your experience is going to be and give other people the ability to comment on it. And then from that, you can build your scene rather fluidly. And we talked a little bit about game design. This is one of the big elements that I always want to think about. When a user is coming into a new world or a new scene, orientation is one of the most important things. You know, if you create a 360 film where you're cutting from one scene to another really quickly, the person does not have the capacity to pull in all that information at once. They need time to stop, to orient. And this is the same thing that happens with game design. The first level of a game is the easiest thing. All you do, you shoot some zombies. Then later on, the zombies come faster, and there's more complex storylines involved. But we want to bring the user in gradually. If they don't understand the rules of the game, if they don't understand the rules of the world, how are they going to enjoy it? I think we've already hit upon raycasting quite a bit. Just to say that in the virtual world, you're a camera and you're a raycast. And wherever you look is a thing that you can interact with. So if I want to have a sound start playing when I look this way, because I want to add immersivity to the audio environment, or if I want to have a thing start walking towards me when I look that way because I've triggered a new door in the game or the world, it happens with raycasting. Also, we've talked a little bit about locomotion and movement. One thing I'd like to hit upon is the idea of teleportation. Teleportation with the Vive is very important because it's a very fluid way to move around a scene. And essentially all that happens is I look that way, and then I would put up a little helper on the world. As you can see on the lower left of the screen, when the user is looking down, they see a little circle on the floor, and wherever I look, that circle goes there. Then if I want to move to that place, then I just hit the button, then I teleport here, I can teleport here, I can go around the world very quickly. And this is one way to solve the problem of locomotion on Vive. On Rift, of course, if you have a controller, they're going to be doing it in a more, let's say, conventional way with a thumbstick. But you can also have problems with this. If I'm pushing forward this way and I start looking that way, I have a disorientation between my intention to go this way and looking that way. It's kind of difficult to see at first, but once you experience it and you feel a disorientation of moving one way and then you feel like your body is being pulled the other way, even though you meant to look that way, it can be very disorienting with fast motion. So that's another thing, is to have slower motion in the scenes because, again, users have to be able to exist within that scene. Once they learn how to move quickly, then you can have a more complex interaction pattern. So what I wanted to kind of get around to closing with is, from the basic user needs, when considering VR, we want to understand, as always, what's the goal? How do I interact with the world? We want to be cognizant of motion fatigue. Also, this is something that's going to be finished with technology or addressed with technology eventually. Because right now, one of the differentiations between a high-end and low-end device is the ability to have a refresh rate which is faster than what our eyes are perceiving. And this is key to giving an environment which is easy to interact with and comfortable to be inside. Virtual reality is, of course, not a magic bullet. It's great. I mean, you can say, we want to pitch a virtual reality project, we want to do 360 filming, and it's great because it costs a bit more, and so it's better if you're a filmmaker or you're a UX designer. It's a great environment. It's a great possibility. But if it's only VR because it's VR, the people aren't going to understand why it was VR. Then the stakeholders will say, oh, okay, this didn't really work out, so because VR doesn't work. No, with all new technologies, they have to be applied in an intelligent way which makes sense for the user. It has to give value. If it doesn't give value, there's no reason to do it. Movement, the way that the person is interacting with the world, this is like the barrier that you have to be cognizant of. This is one of the things that's going to give pause to a person, make it more difficult for them to interact with the environment. And great stories. Content is key in all forms of interaction, I feel, and especially with VR. If you want to have a narrative-driven story, it has to be written well. If you just want to have a shooter game, that's also cool too. You have to be cognizant of what you want to create from the beginning. If you don't know you want to create a shooter game and you create a poetry interactive game, then probably you're not giving what the user wants. I mean, I play Doom still because I just love the way that I move through the levels. The graphics are horrible. It doesn't matter. I just like the interaction play. But I don't like Doom 2016 because it's like this role-play multiplayer game with like really fast action, but it's not what I was expecting. It's not what I want from Doom. From VR, I want to be able to like sculpt and create stuff. From my iPad with Doom Classic, I want to, just play Doom. I want to be able to choose that as a user and get what I am expecting from that experience. The story and the user should come first. Technology is still exploding continually. Over the next year, there's going to be multiple HMDs from a lot of different manufacturers, better fields of view, better refresh rates. It's awesome. But if you don't create a cool experience, then no one's going to care anyways. So, if there are any questions, I'm available, and thank you for your attention.
Thank you so much. That was so inspiring. I have thousands of questions right now. So I can think about, so what about different types of content? You talked a lot about films and games and things like that. And of course for training purposes, which are usually very expensive, but things like shopping maybe, or I was thinking banking. It's something we do on our phone.
Well, I think especially understanding data, like the context of data, is going to be a really interesting user problem to solve. I mean, this is something where we're still working with 2D graphs most of the time. We never work with 3D graphs usually, because even if you have a 3D graph on a 2D screen, it's like you have to dive into it. I'm a scientist. I don't like to look at a 3D graph. No. But in virtual reality, it's a totally different story. If you're a cloud of data, I can like teleport here. I can look at you. Yeah. I can see like what's happening. Maybe I can like add this element here that's modifying the data calculation, and then it'll be a much more intuitive way to explore the world. Because finally, we'll have the connection between our body movements and exploring technology. What do people say? I think I was watching this talk from Amazon at the last startup camp, and they're like, yeah, we make sure our workers, they get up and they get something to drink all the time, to make sure they're moving, because you get better productivity. And it's the same thing for me. You want to move when you're thinking. It's like scientifically proven that you work better that way. And with VR, it's built into the thing. You don't have to say, okay, I have to leave work to go take a run, because, shooting zombies, it's already like, I start to sweat a little bit. So I love the connection that we're going to have between our body and the technology.
And what about, I think the hardware aspect, that's something that's bothering me. And when I look now, my kid suddenly found Pokemon Go. And that's a bit of virtual reality, right?
Well,
and that it doesn't have the limitation of you being just on your own. Mm-hmm. You can actually play it with other people and be walking around. What do you think about that? Maybe
I mean, one of the projects I'd been working on a while ago was a ghost story, which is using augmented reality. And that's also why we want to test it with the HoloLens, and we were hoping that there were better augmented reality glasses coming out beforehand. But I think it's still going to be quite difficult to have interaction in a space. I mean, Pokemon Go, it's a scavenger hunt. Jabanga had this, 7 years ago. I saw people tweeting about this, the game company in Zurich. I think people are playing Pokemon Go because of Pokemon. But the idea of having an interactive environment wherever you are in the world is still a huge barrier for people to understand, because it's not intuitive in the technology that we've grown up with. So I love the idea of augmented reality, but I think it's still going to be very specific to use cases primarily for business, also because of the cost of the hardware. But we'll see. I mean, it's a question of what users like and what's going to make sense.
Okay. Thank you very much. I think we have to stop here. I have tons of questions, and no doubt you all have tons of questions. You'll be around today?
Yeah.
Okay, good. So if you have more questions, be sure to find him and talk to him. Fantastic, really inspiring.